What's going on, you guys? Welcome back to 3D Print Farm. This is the first in a series of videos to hopefully spark some ideas to help you make some extra cash with your fiber laser. But first things first, how about a nice hot slice of pizza? But why use any pizza cutter? Why use any other pizza cutter when you can choose this gorgeous stainless steel Mayan calendar pizza cutter straight from Mesoamerica's favorite pizzeria, Chichen Itza Pizza. That's right, have a nice slice of their Mayan Hawaiian. Or if you'd like something a little more far out, check out this Empire pizza cutter, straight from Galaxy Pizza. All kidding aside, folks, I marked these two stainless steel pizza cutters using the EM Smart One 20-watt fiber laser. And I'm going to show you how to do that right here, right now on 3D Print Farm. So check this out, folks. This blade is solid stainless steel. It is smooth, it is not rough, and I marked it with my EM Smart One 20-watt laser by a process called annealing. What is annealing, you might ask? Let's go take a look. So annealing is the process of applying long-lasting marks to metal. Normally you'll see this in things like cooking utensils, medical products, sometimes you'll see them on tools. And basically what happens is your laser is taken out of focus, it is slowed down, and it is allowing the beam to heat up the surface of the metal, and it causes an oxide film to be generated on the surface to create a particular color. Now the one we're going to be looking at today is black, and again this is just kind of a graphic here of how it works. Again, the laser beam hits the top surface. It does not destroy any of the metal like you would see with ablation or engraving. It's basically just heating the metal just before its melting point to where the stainless steel changes colors. Now, it's not possible with other metals, but things like steel and titanium, it works great for annealing. Again, some of the advantages: it's really gentle on the material. You can wash it over and over and over again. You don't get any of the like residue and things like that sticking down into like an engraving. Again, it says here the organic residue can hardly stick to the annealing, therefore it's particularly smooth. It's great for things to be cleaned like medical instruments, knives, any type of utensils like the pizza cutter that we're going to be looking at. So again, in a nutshell, basically annealing is the process of heating a metal, in particular stainless steel or titanium, until it changes color. Again, we're not destroying anything, we are just creating a black mark on the stainless steel. This is an example of annealing. In fact, this AR Plus cook over here, this was actually annealed onto the blade probably at the factory. This is the one that I just did. So yeah, pretty cool. That is engraved. In fact, you can hear this. I'm gonna take my stick here. This is, you hear that? It's rough like sandpaper. So yeah, that's a nice dark engraving. So this is engraved, this is annealed. Annealed is nice and smooth. There's no sandpaper-like feel. This is engraved. And again, so this is only a 5mm difference in the focal length of the laser. Annealed. Focus. Engraved. So the first thing you do before you buy your pizza cutter is make sure that the disc is removable. Now the one I have here looks like it uses a Phillips head screw. What I'm going to do is I'm going to remove this it's a plastic guard that goes around and basically just pulls off here. and I take a Phillips head screwdriver, and I'm going to unscrew the blade here and make sure that I don't lose that. And as you can see now, I have my, be really careful because this dude is really sharp, I have my stainless steel disc, and I've got fingerprints and looks like some dust from the package in there, so I want to make sure that I clean all that off really good before I set it down to mark it with the laser. But the first thing I want to do before I do anything is I want to take a measurement of this disc. What you'll want to do is you'll want to invest in a set of calipers. Now, I picked these up on Amazon. They're not particularly expensive, but I'll put a link in the description below if you're interested in getting a set of calipers. But you can pretty much pick a set of calipers up anywhere on Amazon or Lowe's, any hardware store that will carry these. So now what I'm going to do is I'm going to take my calipers here, and I am going to measure the outside, if you guys can see this or not, I'm going to measure the outside diameter of the disc, which it looks like it's around 90 millimeters in diameter. What I also want to do is I want to measure the width of the blade. One thing that I really don't like to do when I'm marking or engraving stainless steel is make any marks on the actual cutting surface. Not so much the pizza cutter, because you know you're not gonna, I don't really see yourself sharpening this, but if you're sharpening a knife or something like that, you want to make sure that you don't actually mark into the surface where you're going to be sharpening in it. You know, when you sharpen a blade, you remove some of that material. So I really don't want to mess with the integrity of the edge of the blade. So what I want to do is when I mark this object, I want to mark everything but the edge. So how I do that is I go in and I find the edge with my calipers, and that looks like it is around 2.5 millimeters is the edge. So what I need to do is I need to take 2.5 millimeters here, 2.5 millimeters here, for a total of 5 millimeters, and subtract that from the diameter of this blade, which was 90. So 85 millimeters is going to be our magic number. Let's head on over to EasyCAD and let's set this file up. Alright, let's jump over into EasyCAD and grab our graphic. So what I want to do is I want to go up here to File, Import Vector File, and I'm going to grab this Star Wars graphic. And as you can probably see, well, where in the heck is it? Well, when vectors get imported into EasyCAD, they're usually gigantic. And if you don't see it right here, it's probably somewhere on the work surface. So I'm just going to zoom out with my mouse wheel, and oh boy, check that out. There it is. And I'm just going to click and drag that over to the center. Now, since I have selected the object, you can see these squares around the object. And you look over here, this is the vector file, and it actually tells you the position and the size of the object. So if you remember, our pizza cutter was 90 millimeters in diameter. So I typed in 90, and as you can see, when I typed in 90 in the X value, it automatically changed in the Y value. That's because this little padlock is selected. If this padlock was unselected, or if this padlock was deselected, you could change the Y value to whatever you want. So I'm going to leave it selected. So it's going to shrink it down. So I'm going to click the apply button, or you could click enter on your keyboard. And now, as you can see, your graphic is here, and I can click and drag it over here to my workspace. And now I'm going to zoom in. Now, a quick keyboard shortcut is using the Shift-C button. So with your graphic selected, hold down your Shift button and then click the letter C, and you'll notice that your graphic will snap to the center of your work area, which my work area is 110 millimeters by 110 millimeters. So now I have my SVG, my vector graphic, on the desktop of EasyCAD. Now, as you can see here, it looks kind of like one of those coloring books that were popular here a couple years ago, these adult coloring books, and you can see that everything here looks like like a coloring book, something that you would go in and color in. So that's what we're going to have to do in EasyCAD in order to make the mark on our stainless steel. Now, one thing I did not mention here, and remember, when we pulled this item in, we set it at 90 millimeters in diameter. But if you recall, we measured that edge of that pizza wheel was actually 2.5 millimeters. So what we want to do is, and you don't have to do it, but what I like to do is leave the edge on the pizza cutter bare. So whether you're engraving, or actually, I'm sorry, whether you're marking a knife or anything stainless steel, you want to make sure that you don't mark the edge, because you don't want to reduce the integrity of the metal, especially when you're sharpening it. So I don't expect to sharpen this pizza wheel, but I think it looks kind of cool to have kind of a little edge around it. So it's very easy to do. All you really need to do is go over here to the vector file, make sure that your item is selected, and I'm going to change this to 85, because if you recall, there's 2.5 millimeters from the edge of the wheel to the little edge of the blade is 2.5 millimeters. So if we take this side and this side, we get 5 millimeters. 90 minus 5 is 85. So we're going to type in 85 in here, and I'm going to click enter on my keyboard, and now you can see my graphic has shrunk down, but it is not centered. So my little keyboard shortcut again, Shift C, and now I am centered in EasyCAD. Okay, the next thing I'm going to do is draw a circle, and I'm going to draw a circle. You can see that selected there. I'm going to draw a circle the diameter of the pizza cutter. And I'm going to, since it's already selected, I'm going to click Shift C. And as you can now see, the circle is actually underneath the vector file. See, I've got two objects in here, and this is going to be important when we are setting up our object on the bed of our laser. Alright, so now what we want to do is we want to set our parameters up. And basically our parameters is things like the speed of the laser, the power, the frequency. I'm not going to get into what all of these things do, but I'm going to go down here to select an object from my parameter library. As you can see, I have quite a bit of parameters in here. I am a member of the Laser Masters Academy. I'll put a link in the description below. This is Alex's site for laser everything, and when you become a member of his site, he provides you with the parameter library that you can import into EasyCAD, so you can engrave all different types of metals and whatnot. So what I'm going to do is I've already pre-selected the steel Z mark, which is right here, the steel Z mark black. And for my particular laser, which is a 20 watt, the speed is 50 millimeters per second, and power is 53% at 25 kilohertz frequency, and it's going to do a loop count of 1, which basically means it's going to go through and it's going to run through this exactly 1 time. So now if I was to take this over to the laser, what the laser would do is it would cut all of the lines in here. Remember what we talked about before is this is similar to a coloring book. So if you look here, if I were to take this over to the laser, what it would do is just cut all of these. It would actually mark all of these lines here. We really don't want to do that. We want that nice black colored in appearance. So how you do that to get that colored in appearance is you need to select your object. Make sure that it is selected over here. I'm going to make sure that it is selected. So now I'm selected the vector file and not the circle. And I'm going to go over here to the top and click on this capital H, which is my hatch settings. Now the hatch settings are really interesting. Now what I'm going to do is I'm going to show you just a quick, just kind of a rudimentary way that a hatch works. So what I'm going to do is, as you can see here, there are different types of hatches that you can use. So there's one it's kind of a zigzag pattern. There's one that looks kind of like a snake. There's one that looks kind of like, you know, a square, little square inside of a big square all the way up. And then you've got another type of snake, and then you've got a dotted snake. And then now you're back to the zigzag pattern. So we're going to select that as the zigzag pattern. All you really have to worry about as far as a hatch pattern is concerned is if you think about it this way. So again, looking at this, the zigzag pattern is that what the laser is going to do, and it's going to do this a lot closer than the lines that I'm drawing here. What it's going to do is it's going to go back and forth really fast, but again the lines are going to be like really close together, but it's going to make this pattern of zigzag lines all the way down, and of course they're going to be a lot closer than that. And here, if you've noticed, I have set it at a 45-degree angle, and the line spacing is the distance between these 2 lines here. So the distance between the zigzags, I have it set to 0.025 millimeters. So that is pretty stinking small there. And so at a 45-degree angle, basically what the laser is going to do, it's going to turn this at 45, and it's going to go zigzag like this all the way down, real close together, and that basically will fill in your coloring book. Now I actually have 2 hatches here. I have a hatch 1, hatch 2. You can actually have a hatch 3, but I have a hatch 2, and I have this zigzag pattern selected as well at 0.025 millimeters, but at a negative 45-degree angle. So basically what is going to happen is that it went through with hatch 1 and it drew a 45-degree angle zigzag pattern. Now it's going to come back with hatch 2 and go negative 45. So what's going to happen is you're going to have, you know, this area right here in the middle, zigzag, zigzag, back and forth, back and forth. So it's basically coloring in this area here. And again, that's just kind of a rudimentary explanation, but that's how the hatch function works. So when I'm happy with my hatch settings, again, hatch 1 is at a 45-degree angle at 0.025 millimeters, and my second hatch is at a negative 45-degree angle at 0.025 millimeters. And when I click on OK, now you'll notice that the graphic, hey, check that out, it is colored in like a coloring book. So now you have these nice colored in objects here on your vector graphic. Okay, so now we've hatched our image. We have our second object here, which is that circle, which again will be important here in a few moments. And let's go head over to the laser and get to marking this stainless steel pizza cutter. Alright, I've cranked the laser up, and as you can see, there is a red dot in the center of my work area. I was pointing at the red dot with my focal stick. And what a focal stick is it measures the distance between the lens, and focus out here so you guys can see that. So what the focal stick does, the focal stick measures the distance between the lens and the work surface, or the area that you are going to be lasering. So again, I can adjust the height, and it's very important because what I did initially when I set my laser up, I knew that it was 190 millimeters from the lens to the work surface, and what that gives me is a perfect focus. So the EM Smart is set up with a it's kind of cool. It's kind of a pair of laser dots. Let me focus in on that. I don't know if you can see this. You see how the dots, let me raise it up here. You see how the dots kind of spread out? There's two dots. You can see that really well. Maybe you can see it on my hand. So there's two dots there. That's a little bit better explanation. There's two dots, and as you focus in the laser, the dots will start to converge on themselves. And supposedly, when you get this down here and the dots completely converge, oh, that's too much. The dots completely converge, you're at a perfect focus. Now, as you can see, it's not quite perfect. I mean, I may be off by maybe a half a millimeter or so, but I want it to be as accurate as possible. So again, I cut out a focal stick with my Glowforge, and I believe this is 5 millimeter plywood, and it comes in really handy. The templates for these are out on the Laser Academy, and you're going to have to cut them to the particular size that matches the focal distance of your laser. Again, mine just happens to be 190 millimeters, so your mileage is going to vary. So now that I have my focal distance is set, and I'm going to have to use that in just a little bit. So what I'm going to do is I'm going to take my pizza disc, and I'm going to drop it here on the surface, on the work surface. I'm going to try to line it up as straight as possible. It's convenient that there's a hole in the middle of this blade because I can use that as a guide. It's not going to be perfect, but I can use it just as a guide. There is a red square that is being blasted around the work surface. So this is another guide to help me line this blade up. So what I can do is I can go through here, get it right at the edge, and that looks about right. That's another way to tell that your item is centered on the work surface. But now check this out. Remember the little circle that we drew earlier? So I'm going to go through and I'm going to remove temporarily. I'm just going to do a Control X, which is just a cut, and I'm going to remove the SVG. Let's select that dude there. There we go. Okay. So now I remove the SVG. So now let me fire the laser again. And I'm going to select the Show Contour box. Now the Show Contour box will actually give you a contour of the object that you're going to be marking or burning. So now check this out. Now I have a 90 millimeter circle. So now I can really go in here and manipulate this to where it is exactly how I want it. So I can get in here. Okay, so we've got our object. It's lined up like it's supposed to. The next step I like to do is make sure that our focal distance is correct. Remember what we talked about before? Making sure that the focal distance from this lens to your object is set correctly. Well, I'm going to raise this up, make sure that it is set. Alright, so the focal stick is set directly on the object. The problem that you get into here is that it is completely focused. So you're basically, if I ran the program, you're going to get an engraved mark and not a black mark. So what I want to do is I want to anneal that, because we want to heat the surface of the steel up slowly so we get a color change and not a destruction of the steel. So in order to do that, we have to take this laser out of focus. Now again, your mileage is going to vary on this, but my sweet spot for taking the laser out of focus to anneal and get a really cool black mark is around 5 millimeters. So what I do is I take a 5 millimeter piece of wood, I lay it down on my object, and then I take my focal stick and I raise it up, and I'm lined up. Now, last but not least, you need one of these. This is a bullet level. Bullet level that I like is the Starrett number 135. This is a they're not cheap. They're around 35 bucks, and you're probably thinking, wow, that's really expensive. But this bullet level is super accurate. These are what the machinists and the woodworkers, they love this brand of tool. So what I want to do is I want to set it on my object here and make sure that my bubble is level all the way around. So now what have we got so far? Our object is on the bed. It's set within the parameters of the 90 millimeter circle that we set up. We used our bullet level to make sure everything is level. Again, if the object is not level, you're going to have to shim it with either pieces of paper or maybe tiny pieces of wood or any type of object to get it completely level, because that's really important. If the object is not level that you are marking, you're going to get some distortion, and it may not mark or engrave properly. We made sure that our focal distance was set correctly by using our focal stick, and included the offset by using the little piece of wood. Now all we really need to do is, one more thing. I need to go over to the computer and I need to remove that circle. Remember the red circle that we put in here? I need to remove that layer. I don't want it burned into my work surface. As you can see, I've made that mistake before, and I've got a square burned into the work surface. So I'm going to go over here. Also, one of the most important accessories of the fiber laser, or any laser for that matter, is a pair of laser goggles. Make sure you're wearing these anytime the laser is on. You don't want any accidents. So now I'm heading over into EasyCAD, and I'm going to start the Star Wars calendar mark. As you can see, the light's kind of dancing around the object here. I'm going to try to zoom in, and as you can see, it's already starting to mark. It's actually quite cool to watch. And there she is in all of her glory. That's pretty cool. I mean, it's completely smooth. You see the really nice reflection. You know, these are just two examples, but really the possibilities are unlimited. You know, hit up your favorite local pizzeria Ask them if you can personalize their pizza cutters with your fiber laser. Or how about sports team brandings for that superfan? You know, I picked these up on Amazon for about $5. You could sell these for literally 20, 25 bucks or more. And once you get comfortable with stainless steel, branch out into cutlery, knives. Oh my gosh, you could personalize knives for the local chef, or you could start putting designs on an inexpensive knife and sell them. I mean, the sky is the limit for marking stainless steel. What I would suggest is get a small piece of stainless steel. It can be anything. I mean, I used a paint scraper. Head to your local dollar store and pick up a cheap piece of anything made of stainless. Paint scrapers, I know sometimes the dollar store will have these little pocket knives. Practice on those. I mean, it's only $1. Practice your settings. Practice the height of your laser to your substrate, so you can get either that really super rich black mark, or maybe you're looking for something a little bit lighter. Practice with those items because, hey, they're cheap, right? And then you can move on to cutlery. But please stay away from the silverware drawer. You don't want to get in trouble with your significant other. So what'd you guys think about this video? I know it was kind of part tutorial, part ideas about making some cash with the lasers. I'd love to continue to bring you these cool ideas. Just let me know in the comments below, and I'll continue to bring cool ideas your way to help you make money with either your fiber laser, your CO2 laser, or your diode laser. Once again, thanks for joining us here on 3D Print Farm. I hope you enjoyed yourself. I know I did, and I'm gonna wheel on out of here. We'll see you again next time on 3D Print Farm. Bye now.